I'm all the way from British Columbia. Although he's traveled from many distant places way beyond the air on other continents. He's described himself as an interdisciplinary scientist, which fits very well with what Huxley calls all about our interests are. Geology, archaeology, anthropology, paleontology, be a natural fit with much of what Eric does, as well as George and the other folks in the audience. He studies relationships between humans and landscapes in places as far afield from here as China, parts of West Africa, Japan, many places in Canada, as well as the San Juan Islands. He studies the late Pleistocene and Holocene, most of the Pacific Northwest and soon. He's chair of the Department of Earth and Environmental Sciences at Douglas College, across the border in Westminster, and is also an adjunct at Simon Fraser University. So he came here as European, not me, so without further paddling, I'll let him take over.
Thank you, John.
Oh, there's one more thing.
One more thing. Oh my gosh. No, I'm supposed to get this.
Mug.
Supposed to get this after I have to perform first. Thank you. Okay. As John mentioned, my background is quite diverse, actually. I started out in geology, completed a geology undergraduate degree with an archaeology minor, and then I flipped it over. Took another year, and my minor became my major, and I ended up with a degree in archaeology with a completed degree in geology inside it. Then I went to grad studies, went to the University of Wyoming ultimately, and took a couple of years in geology, my master's program. But I was informed by one of the geologists there that the Holocene wasn't construed to be geological, which was a surprise to me because I thought it was part of the geological timescale. But anyway, they were urging me to study other things, and I really wanted to study the postglacial record and to look at vertebrate paleontology, but also to look at human influences on fauna, things like that. So I took a couple more years and ended up with a dual sort of master's degree, which is nominally anthropology, and on to graduate studies then in geoarchaeology, to PhD studies actually, University of Calgary, geoarchaeology, when it wasn't actually called that yet. But anyway, now I'm going to dim the lights here a little bit. Let's see what we can do to optimize your experience. Is that okay? Good. I want to make sure you can see everything. I'm going to be talking about something fairly close at hand. When I say come to the islands, we've got to get things on the islands, and so we're going to look at the early ecosystem history in relation to the San Juans, which are not too far away, I think. Actually, from my house in Coquitlam, I'm on a ridge looking southward. Across that ridge, I'm looking at Orcas Island. So, you know, although I'm from Canada, I'm not that far away. But I also want to look at Vancouver Island, and somewhere hidden in the record there, we're going to find fossil bison. Strangely enough, they lurk. They're not obvious, and they hadn't been obvious to us for a long time, but my gosh, ocean islands and buffalo, how could this possibly have meaning? Now, I'd want to give some credits up front here. We have a couple of research teams working on this. One is a team working on the San Juans, or with the material from the San Juans. I'm working there together with Steve Kennedy and with Randall Schalk in particular. They are consultants. And on Vancouver Island, I'm working together with Richard Hebda and Grant Keddy of the Royal BC Museum. In addition, there are other people. Bob Mirendorf, the National Park Service, is a geoarchaeologist now working with us on the San Juans project. So gradually the team is accreting members. We've published a couple of papers. You don't need to memorize this for the final, but we published one paper on the San Juan, the Orcas Island material in Quaternary Research, and just followed it up with another one in Quaternary International. There's another paper in the works about the Vancouver Island material. It's in basically advanced draft form, and there'll be more to come. Orcas Island, you're familiar with it. I have to show you the view from my front window, basically with a telephoto, that's what it looks like from Canada when you're looking south at Mount Constitution. You're familiar with the kind of the appearance of the area. Nowadays it's forested, and a number of people have said, I think Chris Piolou, actually, ecologist, she said, you know, a lot of people look at these forests, but nobody really asks the question, where did they come from? Well, actually, some people do ask the question, and the question is usually asked by paleoecologists who are usually pollen experts. And so we're looking at the palynology, the pollen sequence for the area, and there's been a lot of literature about the pollen sequences and the vegetation, the sequence, the succession of vegetation in the region. There are some other loose ends that we have to tie up here. Now we're talking about here Orcas Island, there it is in the San Juans. I'm going to be looking also at Vancouver Island in the region here between Victoria and Saanich Peninsula. Interestingly enough, then part of that is south of the San Juans, and a lot of people don't think about that. You think, oh, you know, Victoria is off to the northwest somewhere. It isn't really, and Vancouver Island, part of Vancouver Island is certainly to the south of Bellingham. So just to put you in some perspective there, I'm sure you all knew that anyway. But maybe for some, Canada is kind of a mystery that's way up here somewhere, but it's not really. We have to think about its ancient history. I'm going to be focusing a lot on Orcas Island itself, which is a bit of a horseshoe shape here. We're going to look at a number of sites scattered around the island, all of which have yielded fossil bison. But we need to think in a more regional perspective. So I'm going to be talking in a specific way. I'm also going to be talking in a regional way and making generalities. And hopefully as I leap back and forth, it won't be too much of a disjunct situation for you. Looking a bit obliquely at Orcas Island, you can see the relief here. There are areas of pretty significant uplands. There's Mount Constitution in there, the sloping one that you were looking at a minute ago from the other direction. Around and about, of course, there are other islands, and San Juan Island is going to be mentioned here. It's certainly an important one, and it also has yielded some fossil material of great interest to us. There we are, again, looking from the north. Now, glaciation. These islands, like the region, were formerly glaciated, and as many of you know, a lobe of ice from the Cordilleran ice sheet extended southward down into the Puget Sound region. And in fact, this ice excavated out or over-deepened the area here. It actually is responsible for some of the geomorphology of the Puget Sound region. Moreover, in its presence, it loaded the area. There was a load of ice here, so the land was also depressed. And when the ice retreated then, not only was this area flooded by rising seawater, but it was also emerging. It was also bouncing back up again. So you've got a really fascinating situation in the late Pleistocene with rising sea level from ice melt and water into the oceans, but the land is also rebounding, and at differential rates depending on where you happen to be. And those rates depend upon the character of the underlying material and also how thick the ice was and how much it was pushed down originally. So the actual rebound is differential, and every individual place has its own history then of relative sea level. We have to talk about relative sea level rather than absolute sea level, because some of these places were fairly static, others were bouncing back significantly. It's quite a history. And Orcas Island has a history that isn't completely explained by, for example, the relative sea level sequence from Victoria, even though it's quite nearby. Now, one of the evidences for glaciation, of course, here we are on Orcas Island looking at a giant boulder that didn't come from Orcas Island. It came from somewhere else. It was imported by one of these ice masses, and as the ice retreated, it left behind the large boulder. And in fact, you can see the faceted surface here. It's been impacted by other stones, pressure flaking going on within the ice. So if you're an anthropologist, archaeologist, you should know then that, by golly, pressure flaking wasn't invented by people. And in fact, pressure flaking is a diagnostic signature of clasts in glacial deposits. The flakes are there too, by the way, in glacial deposits. So if you're ever studying microdebitage, you have to remember that. I'm pushing buttons here and nothing is happening. We'll keep on trying. I may have to go to strategy B. Okay. There we go. Now, prior to the time of glaciation, sort of in the development of the ice sheet, there was a major area developed in front of it, which was, of course, an outwash, a massive outwash. In Iceland, they call these things, in Scandinavia, actually, they call these things sandurs. So this was a sandur deposit or an outwash train. And much of the Salish Sea area here, Georgia Strait, Puget Sound, the Strait of Juan de Fuca, much of this area in the early onset of glaciation was actually filled by this sandur, by these deposits. The glaciers overrode them, and as they retreated quite quickly, and they retreated in this region by, actually, they floated quite rapidly, and so a lot of the ice retreat in this area wasn't by gradual melting, but by the breakup of floating ice. So there wasn't a huge sandur after the ice retreated, and that's important to us because, you see, prior to the ice, this sandur would have allowed animals to move back and forth between Vancouver Island and the mainland quite readily. And they did, and we had quite a significant fauna of animals from before the last ice sheet. So when did the last sheet migrate into this area or expand into this area? It did so after about 20,000 years ago. In fact, we have some limiting dates down in this region, and in radiocarbon years, you're looking at something happening around perhaps 16,000 years ago. By the way, this is through the miracle of paleophotography. I was able to go back in time, and you can see Mount Constitution there, and so it's really a pretty good picture, isn't it? But it's actually from Iceland. But anyway, oh, now the button works again. Good. Okay, it got hung up on something. Well, first of all, I want to back up a little bit, and let's be a little bit over-specific for a little while and talk about some discoveries, because I want to give you a kind of a reason for our interest in this area. In 2005, excavations were going on down here. Of course, you can see the arrow, but in a peat, sort of a peaty wetland, and I'm going to be cautious here and not call it a bog, because bogs are sphagnum, really narrowly defined anyway. You're talking about acidic waters, but there's something very special about this. This was a peaty wetland, woody peat, and these excavations revealed a fossil bison. Oh, it's not working again. I think the battery must be getting down here, so we will go this way. There. This fossil bison was readily identifiable as Bison antiquus, which is a well-known fossil form, but not the kind of thing we really expected to see on Orcas Island, or at least most people. And this was something that the finders were contacted by Steve Kennedy, actually, who is in Sedro-Woolley, and Steve is a consultant with a long familiarity with Orcas Island. So he followed up on this and actually secured the find, basically made sure that it was treated carefully and properly. Actually, it wasn't the first bison to be found from Orcas Island, and when Steve got in touch with me, I was able to say, oh, I've been waiting for this, and because of this. In 1957, Ted Danner, who is still emeritus at UBC, I think in his 80s he's teaching still a course in gemology, but he found fragmentary bison bones in a peaty wetland on Orcas Island, actually down here in the Deer Harbor area. The other find was made over in this region right here near Obstruction Pass. Those bones, I heard about them first. This is really neat. I heard about them in 1968. I was in Vancouver at the time talking to a couple of colleagues, and both Ted and Charlie Borden informed me of this, and Ted actually said, you want to follow up on it, look into that. Well, he had sent the specimens down to Ottawa, to the National Museum, and then they went to Toronto to the Royal Ontario Museum. Loris Russell, a vertebrate paleontologist, looked at them and realized they were bison, but at that time, well, They could be anything, right? They could be 2,000 years old. We had no idea how old they might be. And so they were numbered, they were sort of described briefly, put in a note, and that was that. Dick Harrington, much later on, 1975, assembled these notes, actually, that were made by Loris Russell and put it as an appendix in a paper that he was publishing on fossils from Vancouver Island. So, but Dick actually didn't get to see the specimens because, you see, the specimens vanished about 40 years ago, and we didn't even know where they were. For 40 years, I've been looking for them, or 43 years. No, it was 40 years because I found them 3 years ago. But checked in Ottawa, looked through collections there, checked in Toronto, looked through collections there. And finally, I was at UBC 3 years ago. They were moving some things, and I asked them, have you found any bison bones? And the answer was, by sheer coincidence, the answer was, yeah, a couple of days ago we found a box under a shelf. It's labeled Lummi Island. And so I looked at these, and there they were, the same specimens that were originally found on Orcas. They'd been mislabeled, but they had been carefully kept at UBC. So that was pretty neat. Anyway. I love technology here. Now, other discoveries, as it turned out, had been made in the region. We didn't really understand, you see, the context. We didn't understand the pattern here. What's going on? A horn core fragment had been found in Victoria, of all places, over on Vancouver Island. A fellow named C.F. Newcomb. Newcomb was actually an early natural historian. He collected lots and lots of fossils. And although he was an avocational scientist, he took very careful records, even published some papers. And I'm trying to multitask here and take my watch off so that I can watch what's going on, but I just failed in that mission as well. There we go. Okay. Newcomb first thought he had a piece of elk antler, and then he re-identified it as a muskox, and then he realized, no, it's a bison. Actually, he had help. He sent photographs to other scientists, and they realized it's the base of a horn here of a fossil bison. Another upper jaw, a maxilla, was found in trenching, again downtown Victoria, in 1946 in a waterline trench. And the interesting thing about these ones is that underneath the deposits, and actually Newcomb made a really nice description in 1914, underneath the wetland peat in which at the base of which this specimen was found, were glacial marine deposits with marine shells. So he called it a beach. He called it the Fernwood Beach. And wow. Then we started looking and thinking about these other finds. Danner had noted that in the excavation where the bison was found in Orcas Island, there were also marine shells. He wasn't aware of the one over in Victoria. But a pattern started to emerge. Grant Keddy and Richard Hebda and I were working on bison from Vancouver Island, and I'll show you another discovery in a minute. But very recently, those early sewer line or water line excavations went into a whole new cycle of replacement of pipes. And during the work, there was an exposure of peat over top of early lake deposits, over top of glacial marine deposits with shells. And these are the shells here from down below. A bison tooth was found right at the interface between the peat and the underlying early pond deposits. So we secured that one in place, in situ. But in 1987, this is what got me together with Hebda and Keddy eventually. 1987, a large bison skull was found with one vertebra, came up in a backhoe, again, a backhoe load, in North Saanich, the north end of the peninsula there, north of Victoria. This one was radiocarbon dated, 11,750 years before, oh, now this is interesting, 11,750. This is just after the retreat of ice from the area, so we're talking about the early landscape getting developed, the early ecosystem on Vancouver Island immediately after glaciation. The specimen itself was below the peat, it was in marl, And that's a very neat environment, by the way, because normally in this area, bones don't get preserved very well, do they? You know, if they're in a forest, the forest soils here are slightly acidic, and so bones just don't get preserved. But in these local environments, in wetlands underlain by shelly marine deposits with shells, calcium carbonate, then you've got buffering, and the water is not acidic, unlike a sphagnum bog where the water would be acidic. So here, in this tiny little window of opportunity, you've got the preservation of bones. Okay, another partial skeleton came up in another backhoe excavation in Royal Oak, which is just north of the city of Victoria. And now we've dated that to 10,900. So, now we've got a time range. 11,700, 10,900, something in there. That's getting interesting. So let's look at this in some oblique perspective here. Here we are. There's Orcas Island, San Juan Island. Here's Victoria, the city of Victoria. And when you look at it this way, you realize they're not very far apart. Separated by Haro Strait. Here's Haro Strait. That's a significant body of water. But, well, bison got over there somehow. We've got actually several discoveries of bison, you see now on Vancouver Island. The Saanich Peninsula one, Royal Oak, and a couple down in Victoria. Actually, we've now got 4 specimens, well, 3 specimens from downtown Victoria. And so it's an interesting pattern. Well, back to the one that was found then on Orcas Island in 2005, found on the Ayer property, so we refer to it as the Ayer Pond site. This one was also clearly a bison antiquus. It was in the same setting. The pond excavations were able to have a look at them while the pond was drained. Glacial marine deposits underneath peat. At the very base was a little layer of early pond deposits that are filled in with snail shells and so forth, kind of a marl. And again, the chemistry was just right. And here was this large buffalo. And we got it radiocarbon dated. Initially, our first radiocarbon date, by the way, was 11,760. So we thought, oh, this is wild. It's an identical animal to the one over on Vancouver Island, and it's almost the identical date. Actually, we had an opportunity to redate this one using much more stringent chemical pretreatment. So Tom Stafford, running a lab doing some experimental radiocarbon work. So Tom gave us another date, and the date was 11,990. I suspect that most of the other dates are a little bit young because they're on bone collagen, but they haven't had quite the stringent procedures attached to them. But anyway, so this is actually 11,990 years old by radiocarbon. But it's not the only one out of that particular excavation. As the work proceeded, up came the original skull, but also a juvenile male bison skull, and a toe bone here that is from a mature female. We've got the toe bones from this guy as well. They're very different in size, but they are clearly bison. And so, we jokingly called it the first family here, but what we've got here is evidence for more than simply a couple of wandering animals, you see. This kind of a combination is very important to us because we're talking here then of a population that's probably a sort of like a founder population. You've actually got a group of animals dispersing here rather than a pattern that we do see a lot in bison, which is that the old males tend to wander. Is that like humans? I could wear a sign saying confused and prone to wandering. But bison have this pattern. The old males, they tend to get kicked out of the herds a little bit, and so they do. We find them up in mountain passes and things like that, and they're almost always old male bison. We know that pattern, but this is more than that. It's not just wandering individuals. So it has some real biogeographic implications, and that's why we ask more general questions now. Now, what's happening, of course, is that new finds continue to be made. So there's another one from Orcas Island. That's that partial skull, 10,800 years, maybe a little bit more than that. Another one from a pond near Obstruction Pass again, by the Ayer site. So this is a toe bone here, badly corroded, may even have been worked on by a carnivore, and that one's dated 11,180. But you see the pattern now with the dates. They're all basically the same. They're falling in between about 12,000 years ago and 10,800 years ago. They're all very much similar in date. Other finds. Here's one from another farm on Orcas Island. Here's one from yet another. These are bison, and they're also vertebrae from a site on San Juan, which I'll mention a little bit later on. So even the initial finds that Ted Danner made, once I looked at them, there are two individuals there, a male and a female. Again, we're talking about a pattern of more than just wandering males. Science and maybe science is done by wandering males, but anyway. So we're getting an idea here that these are documenting for us a dispersal corridor. We're actually looking at a dispersal of animals from the mainland, and this is the most logical corridor. You might say, well, why didn't they just cross over in shallow water conditions, say from Olympic Peninsula up to Vancouver Island? Maybe they could have, but then you've still got to explain how they got to Orcas Island from Vancouver Island. So, you know, back and forth. We're really talking about a dispersal corridor here, but we think it's a filter corridor. We actually think it wasn't dry land at any particular time in the postglacial, though it may have come quite close to it. Now, I mentioned that these two animals were very similar, the two skulls, one from Orcas, one from Vancouver Island. They might as well be clones of one another. They are very, very similar. And it's also quite important that their horn cores, although they may look big to you, their horns, they're actually very small for Bison antiquus of that time. Very, very small. And so we think that that might represent an island effect, an insular effect, and something that could have happened quite rapidly. And we'll talk about the significance of that. Just to put it in perspective, here is a slightly younger one from the Great Plains. And look at that, the size of the horns on the Great Plains. These animals, although they're the same species, they're very different in their display morphology. And that's something that could change quite rapidly. That's a phenotypic change that could be related to dietary stress, for example. So, to put numbers on it, I actually constructed a chronocline of bison from the plains. That is, over time here, and the spread of the horn cores, the range for any particular time period on the northern plains, going down to the monarch of the plains right here, which is the puniest bison that's ever existed in North America. But anyway, these guys on the plains were much bigger than the ones that we're getting in Orcas and Vancouver Islands. And that is highly significant. Okay, so here now is what we've got, you see. Here we have finds on Vancouver Island with a date range, 11,750 to 10,900. And we've got the finds on Orcas Island and San Juan with a date range that's almost identical, actually, and maybe closer than we think, because only the one date has been subjected to those really rigid protocols. And in future, we'll be redating material when somebody, well, if I can get Warren Buffett to give me some money, for example. But anyway, so now we got some biogeographic questions. What the heck is happening? We do know that the ice has been advancing, of course, down into this region. We've got some dating control on the advance of the ice as well from other sites. But there was a time here when we looked probably kind of like Greenland here. We have other questions to ask then about the corridor itself and how it developed. Archaeological evidence, when did humans arrive in this area? And did they have anything to do with the demise of these animals? There are a lot of questions to ask. Well, there were certainly animals on Vancouver Island prior to that last glaciation, and they included bison, unfortunately for us. So are we just looking at a survival? They made it through the last ice, maybe in a refugium somewhere. There were other things like Columbian mammoth, there was mastodon, muskox, really quite a variety of things. And so we're confident then that there was a fauna on Vancouver Island, no problem. We've got a date on a mammoth, in fact, from the area of northern Victoria, the city of Victoria, of 17,000 years ago. I just got a date on a mammoth tooth from Hood Canal, actually down here in Puget Sound, and the date that I just received a few weeks ago is 16,960. So there's another limiting date on the animals just before the last ice advance. But the question is, could these have made it through the peak of glaciation? I cannot give you a definitive answer to that, but I can say this, that up in northern Vancouver Island, We worked on a fauna from a cave here. The fauna is dated between 18 and 16,000 years ago. And it included 3 species of voles, amongst other things. We had other things all the way up to mountain goat. But 3 species of voles. So 2 Microtus, long-tailed, Townsend's vole, and then the heather vole, Phenacomys. Only one of those is found on Vancouver Island today. You see, only Townsendii is found on Vancouver Island today. So if there was a refugium capable of supporting large vertebrates, somehow the mice couldn't make it through. And that's counterintuitive in a sense. I rather doubt it, and the geological evidence suggests that there was not a refugium, but of course we cannot exclude that completely. So we're going on the conclusion that the things that existed in Victoria, as you see here, before glaciation, were actually erased away by the ice advance, and the RCMP recolonized Vancouver Island. But anyway, and so we have then a dispersal corridor and probably a filter bridge, because as it turns out, only a few of the things that are on Orcas Island, well, only some of the things that are on Orcas Island and San Juan Island are found over in Victoria. The bison made it across, but they're not everything did make it across. So, what are the settings here? And what else have we got? Other finds on the San Juans include a ground sloth from Orcas Island, a giant ground sloth, Megalonyx. Arctodus, a giant short-faced bear from San Juan Island, in early postglacial deposits, the same series. Do we have them over on Vancouver Island? Actually, the bear apparently did make it over, but so far we don't have any ground sloths. So if they made it that far, they couldn't make it any further, but the bison could. So we're developing this sort of filter corridor model. Well, let's go back and think about the fact that we do have pollen sequences for this area. Typically in the past, we've considered vegetation to be a container for the animals, for the fauna. So when you're doing a reconstruction from the area, you think, okay, ancient climate, vegetation, we look at the interplay between climate and vegetation, then we plug the animals in later on in our analysis. And basically we're saying that the animals were kind of inconsequential, really, in terms of getting this thing started. The plants did their thing, they got established, then the animals were able to be plugged in. And we tend then to wait on behalf of the animals. We tend to wait until the environment was appropriate for them. When we look at ecosystems in this region, we have to remember that each ecosystem actually is the result of 2 different cascades. By that I mean cause and effect sequences. One of them is clearly historical, and we're all familiar with ecological succession. But the key thing is that what you see today, just like a committee meeting, the person who speaks first in a committee is the most powerful person, right? Because everything else streams from what that person says. Think of it in terms of the ecosystem. Whatever happened early on was the first step in everything else that followed. And so those initial conditions really defined in some way what was to follow. And there may even be today anachronisms in this ecosystem, leftovers from previous conditions. They're sort of eking out an existence, but they're really not well suited to the modern conditions. They might be leftovers from some other time in that sequence. Also, we've got to look at an ecosystem as a trophic cascade. Now let's forget about time, just thinking of it right now, that there's a relationship between the plants, the things that eat the plants, and the things that eat the things that eat the plants. So, and it turns out that the predators actually exert quite a strong effect on herbivore populations, and as a result, upon the development of the ecosystem in any one area. That's a much more powerful thing than we ever thought about. To give you a proper illustration of what we mean here, I would go to this picture here and show you that this predator is clearly influencing the prey species, which is clearly influencing the vegetation. But that's my trophic cascade model here. I've been trying to find the origin of that picture, by the way, and I keep trying. I can't find it. But anyway, it's been sent around so many times on the internet. But the role of predators in terms of vegetation change is now being acknowledged in many areas. We'll talk about it a little bit more. Ooh, what else can animals do? There's a whole field of science, you may not have heard about it, called zoochory. There are animals that are exozoochory experts. They transport propagules on their fur. They can transport propagules on their feathers or on their feet. Think of the muddy feet on water birds. Muddy feet on water birds have lots and lots of seeds. And a character named Charles Darwin actually demonstrated this by scraping mud off the feet of birds that were passing through his estate and being able to germinate, I think, 26 different species of plants. Anyway, there are also experts in endozoochory that ingest these various plants and their seeds, and some of the seeds can make it all the way through the digestive tract and then still sprout. In fact, some plants actually depend upon this. That's very important. Ungulates, the big hoofed animals, well, they can then transport these things hundreds of kilometers. It's been documented, actually. In Spain, there have been studies of migrating, people with their sheep migrating back and forth, and of course then studying the seeds that are being left behind by these sheep. So they're good modern studies. But then once they get it going, you've got the herbivores basically stomping the substrate. They're packing it down. What we call the steppe tundra of the late Pleistocene probably couldn't have existed without the packing effect of the large vertebrates that were walking on it all the time, because actually I think you'll find now that mammoths, if they came back, would not be allowed on the tundra because they would exceed federal guidelines for loading of tundra, you see, meaning that they would cause change. But there's selective herbivory too, selective eating, all sorts of other things that these guys can do. So there has been a model already published, and models, of course, are always supposed to be incomprehensible, but this is the Yellowstone model, the wolves and the elk and the aspen. And the interesting thing is, you see, aspen had become very rare in Yellowstone Park in the many last decades. When wolves were reintroduced, one of the unexpected byproducts was there was a sudden flush of aspen. Now Yellowstone Park has lots of aspen. Why? Because the elk, number one, populations are being controlled, and they were grazing down the aspen shoots all the time. Second, elk are actually avoiding places where the wolves are, okay, because the animals, the predators are territorial, the prey species are not. And they're actually moving toward the highways. You know, the elk are moving toward the highways because they view the humans as a bit of a refuge from the wolves now. But anyway, so aspens are popping up. So this is actually where the model has really been demonstrated as important and significant. I always had this idea from the literature that, ecological succession is, oh, it's a slow thing. Oh, God, it's a slow process. And so we got to allow 1,000 years for tundra here and maybe 1,000 years for the pine zone and all this sort of thing. But, of course, that's my brain at work and the illusion caused by reading the literature uncritically and realizing, if you can go to Glacier Bay, for example, areas that were glaciated only 200 years ago, of course, now are being repopulated by organisms, by animals, and also there is initial succession here, and here's a little forest that's sprouting up only 200 years after the glaciers had gone. And so really it doesn't take much time for this to happen. It's an illusion sometimes. In reading the literature, we seem to think it would take a long time, but it doesn't. So I'm going to jump by a few things here that are really unnecessary, but to get to Vancouver Island, and just to point out that there was a sequence here with a lodgepole pine forest, a very open parkland sort of situation, which lasted maybe this long, and then was succeeded by the gradual moving in of various species of trees. But for a long time in the Saanich Peninsula area down in here, it's rain shadow from the Olympic Peninsula, by the way, but you had this patchy area with a lot of species in patches, but including grasslands. So there were little patch grasslands, and we documented that in the pollen from some of these sites. There were poplar-rich areas, and Shepherdea was really of interest because that's the buffalo berry. I know it's an understory plant as well, but it has a relationship to the animals that's worthwhile. So some of these things clearly came in as a result of the activity of birds. Clark's nutcracker, you may know, is a master at the movement of conifer seeds. It's to the Zawakari people, it's called a scatter hoarder. Isn't that neat? I like the idea of a scatter hoarding plant animal. Other things, of course, surely were imported partly by wind activity, and even Henry David Thoreau talked about, I believe it was poplar seeds. He talked about sledding on snow surfaces, actually being windblown across the surfaces of snow. So anyway, the Vancouver Island sequence went over to a mixed coniferous forest, but not until after the bison were there. Habitat suitable for bison actually persisted well after 12,000 in this area here, even when the rest of the island was going over to a mixed coniferous forest. So, the effects of bison on grassland, I think it's now clear enough from what I've said that they actually could be quite influential. Trampling, overgrazing, inhibiting aspen spread, all sorts of things that they could have done. So what I'm arguing is that these bison were helping to craft that landscape. It wasn't just a bunch of plants into which these animals were being plugged. And the carnivores, back to the carnivores. Bears have this wonderful relationship with Shepherdea. They like buffalo berry, they really do, but buffalo berry really, really likes them because buffalo berry germination benefits from scarification in the digestive tract of bears. And so there's a kind of coevolutionary relationship here, perhaps. And perhaps then the richness of buffalo berry in many of our early pollen sequences is a document of the presence of bears. So, dispersal clearly was, it was filtered, unless I can find a ground sloth in Vancouver Island, believe me, I'm looking. It was filtered. These animals probably all had their own individual times of arrival, and perhaps their own individual dynamics of arrival, but they were there. And here is the Arctodus mandible, actually, from San Juan Island. A very large bear, and you get an idea of what we're talking about here with Arctodus. There is a puny little grizzly bear. There is a Kodiak, sort of a round bear, and here's Arctodus up here, giant short-faced bear. Okay, so I've just said this already, and you know this already. So let's think about whether bison can swim or not. Actually, they can. Herds of bison swim across the Liard River up in the Northwest Territories. The current in the Liard is much stronger, actually, than the current in Harrow Strait, the tidal currents. And in the Liard, they swim for many kilometers, actually. So they're good swimmers, and I'm not too worried about their ability to get there, actually, even with the changes that have gone on over time. There would have been Harrow Strait, but, and clearly, ocean levels have changed. This is one of these diagrams of relative sea level change. There clearly have been changes. The landscape was more extensive in the past. So here's Saanich Peninsula. Here it might have been in the past when it was more extensive, but Harrow Strait never really disappears. So we're thinking that this is a filter corridor, and yet an integrated one involving many different kinds of these animals. So, was the vegetation optimal for these animals? Actually, probably not, because we've done isotopic studies of the bones indicating that they were eating a pure C3 diet. C3 plants are adapted, particularly grasses, they're adapted to mesic areas that are relatively wet and cool and so forth. In fact, even today, it's a C3-rich community there. On the plains, it's C3 and C4 grasses that the C4 photosynthetic pathway. These are plants that have greater tolerance for seasonally dry conditions. But the important thing for us is that C3 grasses have only one annual productivity peak, and here it's in the late summer and the fall, according with the rainfall peak. On the plains, then you've got two types of grasses, and they have two productivity peaks. You've got a sort of dry season and a wet season productivity peak. So the productivity is spread out over a long period of time, and the C3 ones on the plains have their peak in the early summer and late spring, in fact, when the females are producing calves, lactating and so forth. The calves are doing their first grazing. That's perfect for bison, but what we've got out here is not, actually. So when we actually look at the isotopic information, these animals were under stressful conditions, dietary stress, having to depend upon one C3 peak late in the season, not at the time when they're lactating, not at the time when the young ones are starting to graze. And so the diminution in the size of the horn cores is probably a direct document of that. They're actually showing us that they were under dietary stress, and the phenotype is changing. The other thing on the plains is that those animals there were getting bigger and bigger until people arrived. Then they started getting smaller. So that chronocline that I showed you of bison getting smaller is probably a document of human predatory influences upon these animals and selection for younger maturation. Here, we might have had people present even at the time of the earliest bison on Orcas and Vancouver Island. The earliest one from Orcas does show signs of having been butchered. It's nicely smashed, a pattern that we're quite familiar with from plains buffalo kills. There are cut marks. There's a big cleaver blow right across here, for example, and there are individual cut marks as well. This is debatable. Of course, people can argue that maybe something else caused these marks, but it's pretty tantalizing, and if we have to throw it out, we also have to throw out the record for the Great Plains as well from the bison kills on the Great Plains. So we can actually then establish a discovery model on the basis of our finds here. We now know where to look for things like this, and we're doing it quite successfully, actually, finding new finds. The elements have got to have rapid burial, of course, the calcareous substrate, all these factors have to be built into it, but we can now focus on this and find more discoveries. So closing it off, the bison were a kind of meta-population, little patchy population that had to be refurbished from time to time from other patches just to keep going genetically. Success was a transitory thing. Dietary stress was always there. And their disappearance corresponded with the arrival in these areas of a mixed coniferous forest. But I leave you with a question. Which caused which? Did the bison help to maintain the previous conditions, or did it leave because the conditions changed around them? And yes, there was younger Dryas environmental change there, but we've got still questions to ask. So overall then, consider you're thinking from an interdisciplinary standpoint. We've got open-ended research here involving paleontology, involving paleogeography, chronology, paleoenvironments, archaeology, and who knows what else. So I do need to close off and acknowledge there are other hypotheses possible. I'm a scientist, of course. So Gary Larson has posited that maybe bison arrived in these places by ballooning. That's actually, he's taking off on what spiders do. Gary Larson lives on Orcas Island. He lives on the far side of Orcas Island. He also suggested that bison might have arrived by cruising, but anyway, there are alternative hypotheses to everything that I've said here today, and of course we're open to all sorts of new ideas. So, thanks to a lot of people, of course, and I'm still looking for the origin of that picture. And there you go. That's the end. Thank you.
We have time for some questions.
Well, I had a question is, when the glaciers had floated and receded, they did not, they left some soil intact then. They didn't scrape all the soil off.
They didn't scrape away all the sediment. So on Vancouver Island, for example, there are some fairly well-developed sequences of deposits there. And those sequences that have the vertebrate remains, over top of them there is glacial till. So glaciers went over top, didn't manage to carve it all away, but were thin enough that they rode over that area without actually eroding everything away. But that's important. That's on Vancouver Island. The main body of that ice was going down the axis of Puget Sound, for example. So that was much thicker ice, and it narrows or it thins as you go east and west from that. So the ice on Vancouver Island, certainly southern Vancouver,